All right, well, here we are on what is the last day of the school week here, and just have a couple of concepts I want to go over, and that'll be it. Okay, so and I think this shows up on that red might be a little faint, but if we had to name this, okay, what we see here in the blue, 3 carbons, what is your prefix? Okay, BPROP. We have an OH group, which means that is OL, so we have propanol. And if we are going to take an acid catalyst, in this case sulfuric acid, so we're just writing SA instead of H2SO4, this is known as a dehydration reaction. Okay, so what that means then is as follows. And I think I'm just going to quickly rewrite this bottom one because I just don't think it shows up on the screen here. So that's probably a little better. Okay, so when we say a dehydration reagent, what does that mean to you? And we can make sense of this, okay? Because eventually what we're going to see on that side is what we would have seen on this side. We certainly hopefully remember this because there is a problem like this on your handout. Because if we hydrate something, what are we adding to it? Okay? Yes, we are adding water to it then. And you could do H2O or HOH, either one. Okay? So in this case, we've got the asymmetrical compound, the asymmetrical reagent. Of course, that gives us 2 products. And we're not going to put the major one. We're just going to put the minor one down here. Because the major product would have had this OH group on that second carbon. Okay? So then if this is hydration then, and this is a dehydration reaction, you're not adding water, you're doing what instead in dehydration? Yeah, taking it away, removing it, whichever. So then one of the things that we maybe had said a long time ago is a lot of these reactions it's all about the water. And to me, I think that's a good way of looking at that. So what we see happening, we take the bond 2, okay, and then notice there's half our molecule up here. So that must mean we need to take one more hydrogen. So you could either take the top or the bottom. So we'll just go ahead and get rid of this one on the bottom. So anything in that box is then going to be removed. So then what we see happening is that carbons, of course, all 3 carbons are still there. Now just remove what was inside the box. Well, we still have these 3 hydrogens. And then this top hydrogen's still there. And then we still have 2 hydrogens here. So then notice we're short on these 2 carbons. So then remember what we said, what was down here is going to look like what we would have up here. So what does that tell you that we need to put? We need to put that double bond right there. So now this carbon's got 4, this carbon's got 4, and of course that carbon's got 4. So then I think a good way that you could look at this, and I think it would certainly make sense, is that these reactions then are reversible, okay? Because you take alcohols, dehydrate them, and you get alkenes. And from prior knowledge, we know we can take alkenes, you can hydrate them, and then get alcohols. So that's what we mean by hydration and dehydration reactions. They're just the opposite of each other. Okay, then what type of alcohol was this? This one up here. Yeah, it was a primary because that carbon's only attached to one other carbon. So on this bottom one, however, when we do this, okay, what type of alcohol are we dealing with now? Because again, we say X marks the spot. How many carbons are attached to the one with the X? So then that would make that a what type of alcohol then? Yeah, that makes that a tertiary. If this was not down here, well then, yes, we would have a secondary. But in this case, we still have a methyl group down there, so therefore that is a tertiary alcohol. This reaction will proceed. This can be dehydrated. The one where it cannot is this one. This cannot be oxidized with either potassium permanganate or potassium dichromate, or even potassium chromate itself. But a tertiary alcohol with these oxidizing agents just cannot do that. And the reason for that is this can get taken off easily enough, but there's not a hydrogen atom down here. It's a methyl group. But it can be dehydrated though. Okay, so in that case, we still know we've got these 5 carbons. Okay, and then that one will still be there. That's not going to disappear. So then if we follow that same path, we're going to put a box here, and then to me, it would probably make more sense to go to the left for our purposes. That's how we're going to look at that. Since there's a methyl group down here, I think it would make more sense that that would get stripped off of there. And you also probably would not be incorrect if you had went to the right instead. So we just redraw everything minus. Well, notice it's not that it's a random hydrogen. It's from the OH. You either got to go to the left or to the right. Okay, and then, and because of this methyl group down here, to me it would make more sense that that would get taken off there as well. And like I said, we're not going to really say, oh, you got to go to the right every time. But for our purposes here, for this one, we're just explaining it in this manner. So we just redraw it minus the boxes then. So these 3 bonds are still here. Okay. Notice that this one's gone. So therefore, we're not going to put anything there. Minus the box here, so that's gone. So that bond is still there. Then the last thing that we need to do then is counter bonds for each carbon. This one has 4. This one's got 4. What about this one? And what about this one? So then from prior knowledge, from what we see up here, we need to fix this in this carbon because they're short on bonds. So, and that's correct. We would only fix one of them if we did this. So I'm going to put a squiggly line there. Okay? So that fixes this carbon, but it doesn't do anything for us there. So therefore, the double bond would have to go over here. Then that fixes all of our problems, and then that would be how that reaction goes or proceeds. All right. So, and I think a practical way of looking at this is when you're removing that OH, you would move closer towards the middle. For our purposes right now, I think that's excuse me, a good way of looking at that is we're not going to go to the outside, we're going to go closer to the middle. So the reason that I wanted to go through this one is that primary and secondary alcohols both dehydrate, they both oxidize. Tertiary alcohols do not oxidize, but they can dehydrate. Okay, I didn't want to go through a whole lot today because important day, so we're right at 10 minutes now. So if there's nothing else, those papers that were handed out will be due on Tuesday, and so we'll give you a little bit of time for when you return. Anything you would like to add back there? We're good? All right. So best wishes today, ladies, so we will catch up to you next time.